This is most important question in sequences and a series. Now, here the question is the sum of n terms of the series 1 by 1 plus 1 square plus 1 power 4 plus 2 by 1 plus 2 square plus 2 power 4 plus 3 by 1 plus 3 square plus 3 power 4 plus and so on. That means here the last term will be the nth term. First of all, you have to find that what is that last term, nth term. So nth term will be Tn is equals to, this one is, by observing that given series, the numerator value 1, 2, 3 and so on. So the last one will be the nth term, numerator value is that n divided by, and denominator value by observing all the terms in the given series. First term is a 1 plus 1 square plus 1 power 4. Second term 1 plus 2 square plus 2 power 4. Third term is 1 plus 3 square plus 3 power 4. So here we can observe that in nth term the denominator will be 1 plus n square plus n power 4. So this is the denominator value in nth term. Now here this one, how can we simplify? See, look at this one. Here n whole divided by n power 4 plus n square, I will write that 2 into n square minus n square. I will write that n square as the 2n square minus n square plus this one is at 1. After this value, you can write that n whole divided by, here n power 4 plus 2 into n square plus 1. All this you write in that one bracket minus n square. So after that this one will be n whole divided by n square plus 1 whole square, n square plus 1 whole square minus n square. Very clearly the denominator value is a square minus b square, a square minus b square. So this one we can write that n whole divided by a plus b into a minus b. A plus b means n square plus 1 plus n. This is that a plus b. And a minus b is that n square plus 1 minus n. So this is that this one, the denominator can be resolved as the two factors. Now very clearly the difference of these two factors will be 2n, right? So here I will multiply and divided this one with the 2. So here the numerator you can write that 2n. Here the numerator part will be, this one is at 2n. Now 2n you can be replaced with this one is equals to 1 by 2 into 2n. You can write that n square plus n plus 1 minus of n square plus minus n plus 1 whole divided by n square plus n plus 1 into n square minus n square minus n plus 1. So now this one you can write that, you split that two fractions. So this one will be equals to 1 by 2 into n square plus n plus 1 by that these two factors, n square plus 1 will be cancelled. So you can write that 1 by n square minus n plus 1 minus n square minus 1 plus 1 will be cancelled. Now it becomes that 1 by n square minus plus n plus 1. So this one is that nth term. So already in the previous videos we discussed to find that sum of the n terms. This is that what Tn value. To find the sum of the n terms, you take that sigma to this one. So therefore sigma Tn is equals to, so here you write that n value is that from 1 to n. suppose you write that t1 t2 t3 and so on. So n is equals to 1. If you write that 1 by 2 into 1 by 2 into this value will be 1 by 1 minus 1 by 3 minus 1 by 3 plus, and n is equals to 2. If you write that 1 by 3 minus, so this value is that 1 by 7 1 by 7 plus n is equals to 3. If you write that 1 by 7 1 by 7 minus, so here 9 plus 7 10 10 plus 3 is 13 1 by 13, okay, plus and so on, that plus the last term n is equals to n, that value is that 1 by n square minus n plus 1 minus of 1 by n square plus n plus 1 n plus 1. So this one is the last term. Now by observing this one, here minus 1 by 3 plus 1 by 3 minus 1 by 7 plus 1 by 7, so up to these terms it will be cancelled. So what is that remaining term? The remaining term will be 1 by 2 into 1 by 2 into this value will be 1 minus 1 by n square plus n plus 1 n square by 1 by n square plus n plus 1. Now you take that LCM. So this value will be equals to 1 by 2 into this value will be, by taking the LCM, n square plus n plus 1 minus 1 whole divided by n square plus n plus 1 n plus 1, okay. So now here plus 1 and minus 1 will be cancelled. So what is that remaining value? This value will be equals to, that is equals to 1 by 2 into 1 by 2 into n square plus n whole divided by n square plus n plus 1. So this is the final result. It shows that sum of the n terms of the given series, this one is that sum of the n terms, sum of the n terms of the given series. Now suppose the same question, if you want that sum of the infinite terms, sum of the infinite terms means s infinitive, this one will be find that 1 by 2 into, simply you take that limit n is tendings to infinitive, here it value will be n square plus n whole divided by n square plus n plus 1. So whenever the limit is that limit n is tending to infinitive, you have to divide numerator and denominator with the n square. Now it becomes that 1 by 2 into limit n is tending to infinitive. See, what is the highest? Numerator is a polynomial, denominator is also polynomial. So whenever while finding the infinite limits, you should be divide numerator and denominator with the highest power of the term. So that means here is that divided with n square by n square plus n by n square whole divided by, here is that n square by n square plus n by n square plus 1 by n square. Now here you know n by n square is that 1, here n and n will be cancelled, here also n square cancel, n and n will be cancelled. The resultant value will be equals to 1 by 2 into limit n is tending to infinitive, that is that 1 plus 1 by n whole divided by 1 plus 1 by n plus 1 by n square. You know n is tending to infinitive, 1 by n is tending to 0. So that means 1 by 2 into this value will be 1 plus 0 whole divided by 1 plus 0 plus 0. So your right answer will be equals to 1 by 2. So therefore sum of the infinite terms of the same series will be equals to 1 by 2. So I hope that everybody is clear this problem. Thank you for watching this video. Please like, share and subscribe the channel.